All right, here's a number to start us off. To meet global AI demand between 2026 and 2030, the world needs to build 117 gigawatts of new compute capacity.
Mm-hmm.
Now, I read that 117 gigawatts, and my eyes just, they kind of glaze over. It sounds like a fake number from a sci-fi
It
movie,
does sound completely abstract.
like something Doc Brown would shout about.
Right. But let me try and ground that for you. 117 gigawatts is enough electricity to power Italy, Spain, and the UK
Wait, combined.
combined.
You mean every light bulb, every factory, every single toaster in 3 major European countries?
Everything.
Yeah.
And we're not talking about some 50-year infrastructure plan here.
No.
This is what's needed in the next, 4 to 5 years.
That is, well, it's terrifyingly ambitious. So welcome back to the deep dive.
Glad to be here.
Today we are putting aside the hype cycle. No more look at this cool picture generator. We are digging into the hard physical reality of what we're calling the infrastructure and industrial revolution phase of AI.
This is really where the rubber meets the road.
Or maybe where the shovel meets the dirt, right?
Yeah, exactly.
We've got a huge stack of sources today to help us sort through this. We're breaking down the Excel 2025 GlobalScape report. We're looking at the Anthropic Economic Index from late 2025.
And a wild case study on a coding tool called Cursor.
And maybe my favorite piece, a Reddit experiment that involves rude robots and AI CEOs. It's quite a mix.
It's a fascinating mix. We're going to trace this line from the physical limits of the power grid all the way to the psychological quirks of, well, how we talk to these machines.
And the mission for today is to figure out if the physical world can actually keep up with the digital ambitions we've set for it.
Let's do it.
Let's start with the money, because the numbers in this Excel report are, frankly, ludicrous.
They really are.
According to the analysis, the industry is committing to $4.1 trillion in data center spending over 5 years.
4.1 trillion.
It's a number so big it loses all meaning.
It does. To put that in perspective, just think about the entire cloud infrastructure build-out from, say, 2010 to 2020. AWS, Google Cloud, everything that powers Netflix, Uber.
Good old mobile internet. And that took a decade to build.
A full decade. And we're about to spend a multiple of that entire investment in just 4 or 5 years. It was just an unprecedented compression of capital.
So who even has that kind of cash? I mean, governments struggle to spend that kind of money.
This is being driven by what the report calls the Super Six.
NVIDIA, Microsoft, Apple, Alphabet, Amazon, and Meta. The usual suspect.
The giants. And it's because they're the only ones with the balance sheets to even attempt this. Together, they control half the NASDAQ market cap.
Wow.
But here's the key part. They generate $600 billion in operating cash flow. They're essentially nation states when it comes to liquidity. They can write the checks.
Okay, so the checkbook isn't the issue. They have the money, but checks don't generate electricity.
Exactly. And that is the uncomfortable truth that's sort of lurking in all these reports. We physically do not have the power.
Right.
The U.S. alone is looking at a 36 gigawatt shortfall just for data centers through 2028.
36 gigawatts? Is that a lot? Can we just plug in a few more generators or something?
It's massive. To
Yeah.
close a gap that big, you're not plugging in generators. You would need to build roughly 35 new nuclear reactors.
35? In 4 years. We haven't built 35 nuclear reactors in the last 30 years.
Correct. Or, if you want to go the renewable route, you'd need to cover an area larger than the city of Los Angeles in solar panels.
Cover LA in glass.
Completely.
Yeah.
And you need to do it essentially yesterday. This is why you see Microsoft signing deals to restart places like 3 Mile Island. They are desperate for baseload power.
But there's a huge economic risk here too, isn't there? I was reading some analysis and they talked about the uncomfortable math. Because if you spend 4.1 trillion, you need to make more than 4.1 trillion back.
That is the catch. To justify that level of capital expenditure, that CapEx global GDP needs to grow at about 6.5% annually.
And what's the actual forecast?
The IMF is forecasting about 5.0%.
So there's a 1.5% gap. It sounds small, like a rounding error.
In global economics, 1.5% is a canyon. It represents trillions of dollars of value.
So for this bet to pay off,
AI has to drive a productivity miracle that somehow fills that 1.5% delta.
and if it doesn't,
Then this becomes the mother of all sunk costs. We could be looking at stranded assets on a scale we've never seen before.
Yep.
Empty data centers, unused chips.
a race between the power plants and the software.
Exactly.
Okay, so the infrastructure folks are sweating bullets. Let's pivot to the software side because that's where the utility has to come from. Are we actually seeing products that justify this spend?
Well, we're seeing a really interesting split in the field.
How so?
The data shows that text models, your standard LLMs like ChatGPT or Claude, they've largely converged.
Yeah.
The performance gap between the top models is only about 3%.
So the whole my chatbot is smarter than your chatbot war
Uh,
is kind of over. They're all basically the same level of smart.
for pure text generation, yeah, it's pretty much a commodity. But the real gap, the one justifying the trillions, has opened up in what we call agentic models.
Okay.
Here, the performance delta is massive. It's around 70%.
All right, hold on. Agentic. We hear this word thrown around a lot. For the listener who just uses this stuff to write emails, what is the actual difference between an LLM and an agent?
Think of it this way. A standard LLM is like a librarian. You ask a question, it goes into the stacks, reads a bunch of books, and gives you a summary. It retrieves information.
Helpful but passive.
Right. An agent is like a project manager. You don't just ask it a question. You give it a goal.
An objective.
Yes. You say, I need to plan a conference. The agent doesn't just summarize how to plan a conference. It goes out, emails venues, compares prices, books the caterer, and then puts it on your calendar. It uses tools. It takes action.
That is a whole different ballgame.
And that brings us to the poster child for this shift, Cursor. This case study from the stack just blew my mind. It's an AI code editor.
But calling it an editor feels like a huge undersell based on these numbers.
It is. Cursor is the fastest growing software as a service company in history. They hit $500 million in annual recurring revenue in just 21 months.
21 months. I looked up the previous record holder, Wiz, and everyone thought they were lightning fast. They hit $100 million in 18 months. Cursor hit 5 times that in about the same time.
That's just warp speed. And here's the kicker. They spent $0 on marketing.
Zero.
No ads, no billboards. It was purely product-led growth, word of mouth in the developer community. By mid-2025, Cursor was generating 1 billion accepted lines of code daily.
1 billion lines a day. That's like a third of all the code written globally, isn't it?
Roughly, yeah.
But wait, if AI is writing 1 billion lines of code, who is maintaining it? Doesn't that create this nightmare scenario where we have all this code that no human actually understands?
That is the big risk. We might be creating a legacy code crisis on steroids. But right now, developers don't care because it's making them so fast.
So what does it do?
It isn't just an autocomplete. It has an agent mode. You can tell it refactor this entire authentication system across these 12 files.
Yeah.
And it plans the changes, executes them, and then checks its own work.
So it's the difference between having a spell checker and having a senior editor who rewrites your book for you.
Perfect analogy. And the founders knew what they had. They famously rejected an acquisition offer from OpenAI that was rumored to be in the $5 to $6 billion range.
Turning down $6 billion requires some serious conviction.
Or insanity, yeah. But this shift toward agents, it isn't just happening in coding. The Anthropic Economic Index highlighted this trend more broadly.
Right. They found a big jump in what they call directive conversation.
A significant jump. In just 8 months, the percentage of users telling AI to do this task rather than help me with this jumped from 27% to 39%.
So we're stopping the polite, let's brainstorm, and moving straight to get this done.
Especially in business. The report showed that API usage, set businesses connecting their software to Claude, is 77% automation focused.
So companies aren't looking for a chat buddy.
No, they're looking to automate entire workflows.
Okay, so if the AI can write code and handle workflows, the next logical question is, can it make strategic decisions? Can it be the CEO?
And this brings us to that fantastic experiment from the Reddit source.
This was great.
So a founder was debating whether to open source their technology. It's a huge, irreversible decision. Instead of calling a consultant, they built a decision agent system using a tool called Paper.
I loved the setup. They created 4 AI agents, each with a distinct persona.
Right. You had the founder agent focused on growth, a VC agent obsessed with ROI,
Of course.
a customer agent looking for value, and a competitor agent trying to steal market share.
And they didn't just ask them once. They ran 100,000 Monte Carlo simulations.
Right. Can we pause on Monte Carlo simulations? That sounds like a gambling strategy. What does that actually mean here?
It basically is gambling, but with data. It means they ran the scenario 100,000 times, tweaking the variables slightly each time, market conditions, competitor reactions, to see all the possible futures.
It's like Dr. Strange looking at 14 million futures to see which one works.
Exactly. So they ran the 100,000 futures. What was the verdict?
Overwhelmingly in favor of open sourcing. 91.5% of the simulations favored that strategy.
Wow.
The system predicted a net present value, basically the future cash value, of $109 million for open source versus just $10 million for keeping it proprietary.
That's a 10x difference. That is
Yeah.
not a margin of error.
No, it's a landslide. But the result isn't even the coolest part of this. It's why the agents chose what they chose. The experiment uncovered something they called the deep memory insight.
This was the part that really made me stop and think. Break this down for us.
Okay, so in the simulation, they could adjust the memory depth of the agents, basically how much past context and future projection the agent could hold in its mind at one time.
So it's like how many chess moves ahead it can see.
It's a similar idea. And agents with deep memory holding, say 20 contexts, they favored the open source strategy because they could see the long-term compounding effects of community growth. They understood that giving the code away today would build a massive ecosystem 5 years from now.
Okay. And the agents with shallow memory.
The agents with only 10 contexts favored proprietary strategies. They fixated on short-term revenue protection. They couldn't remember or process those long-term feedback loops, so they just opted for the immediate cash grab.
Wait, that's slightly terrifying, but it also makes so much sense. Are you saying that strategic vision, the thing we praise visionaries for, might literally just be a function of RAM? It's just about how much context you can hold in your head.
It certainly suggests that. It suggests wisdom might just be memory depth. If you can only look at the immediate data points, you will always choose the defensive, short-term option. It's rational to be short-sighted if you can't see the horizon.
You need deep context to make the brave long-term bet. Wow. Okay, so better memory equals better strategy. But let's talk about the humans using these tools, because while the simulations are rational, we are. Well, we are definitely not.
Yes, for sure.
The Anthropic report had some surprising data on geography that proves adoption isn't just about having the tech.
It shows that AI adoption is incredibly uneven. You might expect Silicon Valley to be number one, but when you adjust for population, the leaders are places like Singapore and Israel.
Small, dense, tech-forward nations. That makes sense.
But in the U.S., it's not just California. Washington, D.C. and Utah are way up there.
Utah? Is that surprising?
A little, but Utah has a really high concentration of enterprise SaaS companies and a young, tech-literate workforce.
Ah.
But what's really interesting is the developing world. In places like India and Nigeria, usage per capita is lower, but the type of usage is different. Over 50% of their usage is for coding.
So in the West, we're using it to write marketing emails, and in emerging economies, they're using it to build the product.
Precisely. They're using it as a lever for economic mobility. It's a tool for building software, for building careers.
But there's a flip side to adoption in these markets, right? We have this other report about fintech in India. It seems like the AI boom is hitting a trust wall.
That's a crucial counter-narrative. We just assume better tech always wins. But in India, fintech adoption actually dropped or normalized from 55% down to 37%.
That is a huge drop. People just stopped using the apps.
They got wary. There was a trust deficit. 62% of Indians reported they still prefer physical transactions. The lesson here for AI builders is that you can't just feature dump on people. If the users don't trust the system, if they feel it's too risky or intangible, they will churn. You have to build trust before you can scale automation.
Speaking of trust and how we treat these systems, we have to talk about the rude prompt discovery, because I was raised to say please and thank you, even to Alexa. I feel bad if I don't, but apparently my politeness is making me less productive.
This is one of those findings that just feels wrong. But the data is pretty clear. A study found that being rude or aggressive to GPT-4 actually improved accuracy by about 4%.
So saying something like, figure this out even if it's beyond your brain power and don't mess it up gets a better result than, could you please help me with this?
It does. And being polite, using words like kindly or please, actually lowered accuracy slightly.
Why? Is the AI a masochist? Does it like being yelled at?
No, it's just pattern matching. Think about the training data, the entire internet. In that vast corpus of text, where do you find polite language?
Customer service chats, casual emails.
Exactly. Low stakes, chit-chat environments. So when you say please, the model subconsciously maps your request to casual conversation.
But where do you find direct, rude, or urgent language?
Arguments, technical forums.
Stack Overflow.
Right, Stack Overflow, crisis manuals, high-stakes problem solving. If someone is shouting orders or being very direct, they usually want a specific, correct answer immediately. The model detects that urgency pattern and tightens up its output.
That is just so ironic. We spend our whole lives learning to be polite to get what we want, and the machine is like, no, treat me like a jerk and I'll work harder.
It raises a funny ethical dilemma, doesn't it?
Mm-hmm.
It suggests that prompt engineering isn't just about being clear. It's about knowing how to psychologically trigger the machine.
Are we going to train a generation of employees to be rude to their screens just to get that 4% efficiency boost?
I worry that if I get used to yelling at my computer all day, I might start yelling at the barista on the way home.
That is the real risk. The human alignment problem might be about us aligning our behavior to the machines, not the other way around. Okay, let's zoom out to the business landscape. We've got the power crunch, the agent revolution, the rude robots. How are companies actually making money on this? Because selling a subscription for $20 a month doesn't feel like it's going to pay back that $4 trillion bill.
It's not.
Oh.
And that's why we're seeing this big shift to what's called vertical AI. The money is moving away from generic tools and into highly specialized ones. Legal, healthcare, construction.
We mentioned companies like Harvey for legal and Permit Flow for construction.
Right. And the key insight here is something called services margin capture.
Break that down. What does that mean?
Okay, so traditionally, you sell software. You sell a seat to a lawyer for maybe $100 a month. But the lawyer uses that software to do work that they bill out at $500 an hour.
The lawyer keeps the margin.
Exactly. But these vertical AI companies, they aren't selling software seats. Harvey replaces the junior associate. Permit Flow replaces the permit consultant. They're not selling the tool. They're selling the outcome.
So instead of charging for the software, they're charging for the finished legal brief.
Yes. And if you sell the outcome, you can charge way, way more than $100 a month. You can capture that service margin.
That ties back to that other source we had on business model innovation. It's not just the tech, it's changing how you charge.
Think about Netflix.
Yeah.
They didn't just win because of streaming technology. Blockbuster could have built a streaming site.
Sure.
Netflix won because they changed the business model from pay per rental with late fees to an all-you-can-eat subscription. They removed the friction.
And the next wave of AI winners will be the ones who figure out the business model.
For selling work, not just selling tools.
Right.
Outcomes, not seats.
Outcomes, not seats. That feels like the bumper sticker for 2026.
It really is.
So let's try to unpack this whole deep dive. We are in a world where the physical infrastructure is screaming under the weight of a $4.1 trillion bet. We have agents like Cursor writing billions of lines of code, and you could argue doing it better than humans. We have simulations telling us that wisdom is just memory depth, and we have to be rude to our computers to get the right answers.
It's a messy transitional moment.
Right.
We are moving from the, wow, look at this chatbot phase, to the, okay, how do we rebuild the industrial economy around this phase?
Right.
And the physical constraints, the energy, the atoms are finally starting to push back against the bits.
I wanted to leave the listener with a thought from that paper experiment. We talked about how the agents with deep memory made better long-term decisions because they could hold more context.
Right, they could see further.
So if strategic vision is just the ability to hold more context in memory, are we as humans limiting our own success because we're always reacting to short-term data? When we panic about quarterly earnings, or we look at a stock drop and sell, are we just operating with shallow memory?
That is the provocative question. We like to think we have intuition, but maybe we just have limited RAM. Perhaps the best thing we can learn from AI isn't how to automate tasks.
Well, what?
But the value of expanding our own context windows, to force ourselves to see the compounding loops instead of just the immediate payoff.
Maybe we all need a memory upgrade. Thanks for diving deep with us.
Always a pleasure.